Hi guys, so today we're going to go over solving log equations. Just like with exponential equations, when you want to eliminate a log base, you would apply an exponential base of that same value. And keep in mind, domain, that you cannot take the log of any value less than or equal to zero. If you try to plug that into your calculator, log of zero or log of -1, it comes out error depending on the type of calculator you have. But x should always be greater than zero. So just make a note of that when it comes to a log function. All right, so we're going to start off by solving. In this case, I would just like to get x by itself. Now keep in mind that this 3x belongs to the log base of 3. So these are going to stick together. However, the 7 is free to go. It is being multiplied because nothing's happening to it, like there's no plus, minus, nothing's there, so it's being multiplied, so that means we get rid of it, move it to the other side by dividing it. I'm left with log base 3 of 3x equals 3. I really didn't do that intentionally, but there it is, all threes. Now, do not fall for this because I don't know if this is just a trick that some people do, but this is not an exponential base. It doesn't have an exponent, so these don't get rid of each other. This is just a log base of 3 of 3x. So I need to get rid of this log base of 3 in order to get to x because my goal is to solve for x and get it by itself. So to get rid of this log base of 3, I am going to use an exponential base of the same value. So that means I'm going to give an exponential base of 3. Whatever I do to one side, I do to the other. Since this is an exponential base, that means that everything in green has now become an exponent. So just like we did in exponential equations, when you have an exponential base and a log base of the same value, they get rid of each other. Now, without an exponent, or I'm sorry, without an exponential base, you no longer have an exponent here with 3x. So that just comes down as 3x. However, on the right side, that exponential base 3 has not gone anywhere. So this is 3 to the third power. If you know your exponents, you can divide by 3 and just simplify from there. But you can also, from here, just expand it. So 3 to the x power, or I'm sorry, 3 times x equals 3 to the third power, which is 27. And from here, we isolate x by dividing 3 on both sides, and that'll give me x equals 2, 9. All right, remember what we talked about previously. You cannot take the log value of a number less than or equal to 0. So with that stated, for number 2, you're finding the domain of 17 log base 10. If you don't see a base there, it is a base of 10. Log of x plus 8. The only thing that we know is that we cannot take the log of any number less than or equal to 0. So that means x plus 8 must be greater than 0. And in order for that to happen, all of the x values must be greater than -8. And if we try that out and we plug it in, it works because if you pick a number greater than -8, let's say 2, 2 plus 8 is 10, we can take the log of 10. So writing it in domain form, x such that x is greater than -8. I understand that they also put x is an element of all real numbers. That's just going to be standard in the multiple choice, but I pretty much just note the restrictions. This is the way I'm used to writing it. Okay, so then moving on, we come across another solving problem. So I want you to keep in mind that when there is no log base, it's a base of 10. Now, it is being multiplied to -1. So before we do anything with x and base, let's just get rid of the -1. Since it is being multiplied to -1, we're going to divide both sides by -1. And that'll give me -3.5 equals log base 10 of x. Now, this has a log base of 10, which means in order for me to get to x, I need to get rid of this log base of 10, so I am going to give it an exponential base of 10. Whatever I do to one side, I do to the other. So this becomes 10 to the negative 3.5 power equals the exponential and log of the same base are gone, leaving you with just x. So we have 10 to the negative 3.5 power, and that will give me 0.000316228. I'm obviously not going to leave it this way, but I wanted to make sure that scientific notation is noted in case you don't remember. We're going to move this decimal 1, 2, 3, 4 times. So this becomes 3.16 times 10 to the negative fourth because I moved it 4 times. All right, guys, hope this helps.